over 1.5 expressions involving absolute value. So this is a shorter section. Um, so here it says I can evaluate absolute value expressions. The absolute value of a number is its distance from zero on a number line. So they show the key concept in word symbols and examples. So in words, from any real number x, if x is positive or zero, then the absolute value of x is x. If x is a negative, then the absolute value of x is the opposite of x. So in symbols, it says for any real number x, x equals x if x is greater than or equal to 0, and x, the absolute value of x, equals negative x if x is less than 0. So here it says if x equals 12, then the absolute value of x is 12 because 12 is greater than or equal to 0. Where if x is negative 7, that's the second part when it's less than 0. So we would take the absolute value of x, which showed negative x, so negative of a negative 7, which makes it become a positive 7. So basically, if you're taking the absolute value, since it's the distance from that number to 0, it's always going to end up being a positive value. So here, in example 1, it says write an absolute value expression. The accuracy of a meat thermometer is the positive difference between the temperature reading on the thermometer T and the actual temperature of the meat M. Complete the statements about which expressions are and are not equivalent to the accuracy of the meat thermometer. So the one condition is it has to be difference, which is subtraction, which all 4 of these have subtraction. So all 4 of them meet that criteria. So it is mainly going to be whether the outcome is positive or not. So if we're thinking about this, it has m minus t, and then in absolute values. So if I were to subtract them, so let's say the meat was 150 and the thermometer says it was 151. I would take 150 minus 151. That gets me negative 1. But then I apply the absolute value, and the absolute value of negative 1 is 1. So no matter what your m and t are, in this case, you'll be getting a positive value. So m minus t in absolute values does work. It fits our criteria. So that one is going to be equivalent. So we'll go ahead and we'll write that in there in just one moment. So I'll pull up my tools. Pen. Luna. Alright, so here, when we go to write this in words, we would say it is equivalent and the reasoning would be is that it shows difference, which they all do, but the second reason is that this one will always be positive. So if we focus on this next one, where I let m be 150 and t be be 151, if I take the absolute value of 150, that's 150. If I take the absolute value of 151, that's 151. But then if I take 150 minus 151, that gets me negative 1. So in this case, it's not positive. So this one is not equivalent. And the reason it's not equivalent is it won't be equivalent when t is bigger than m, because you're applying your absolute values first. Okay. So the next one, let's say that our temperature was 150 and the meat is supposed to be 151. So we would take 150 minus 151, which is negative 1 again. But then we apply the absolute value, which makes it positive 1. So this one is equivalent. And it's because it shows difference once again. And because we're applying the absolute value at the end, it's always positive. Okay. So if we do the same thing for this one, I said T was 150, M was 151. So they want us to do absolute value first. So the absolute value of 150 is 150. The absolute value of 151 is 151. Then we subtract. So if I take 150 minus 151, that gets me a negative 1. So this one is not equivalent. And the reasoning is because it's going to be negative when our M is bigger than T. So the first and third were always positive, but then the second and fourth ended up being negative, depending on which one was bigger. So here we have check amusement parks. At an amusement park, a vendor attempts to guess a person's weight. If they are not within 3 pounds, the person will win a prize. If a person weighs 168 pounds and the vendor makes a guess of X pounds, which expression represents the number of pounds a winning guess is away from the actual weight? So when we're thinking about this, we know that they have to be within 3 pounds of what the person weighs. So we want to see if the number, once we've subtracted, is less than 3. So we would need to subtract what the person weighed, which was 168, and what the person guesses, which was X. So we're looking for the one that subtracts 168 and X, which if we look at those options, that would be option C. We wouldn't want to subtract 3 because that's not showing if they win or not, because we want this number, once we've subtracted, to be either 0, 1, 2, or 3. And that would show us if they won or not. So these next, 4, want us to evaluate. So they give us what some variables equal. They ask us to plug it in, solve, and see what we get. So this one here, we have the absolute value of -2. Instead of X, it says 6. Instead of Y, it says it's equal to -3. And then we have plus 5 times the -3, absolute value. So then we do our order of operations. Absolute values act as grouping as well. Now everything in here is in the absolute values, so it's all within that grouping. So then we do exponents, which they're on or none. So we move on to multiplication, division, left to right. So we would take -2 times 6, which is -12, times the -3, which is positive 36. Then we have 5 times the -3, which is -15. So we'd have -15. And then these are in our absolute values. So we would take 36 minus 15, which is going to get us 21. Now that's still technically in absolute values. Then we take our absolute value. So how far away is 21 from 0? Well, that's 21 units. So our answer here is 21. So they want us to do that same thing in this next problem. So it says evaluate. We have a negative sign on the outside. We got absolute values. We have 5. Instead of A, they want us to plug in -2 plus 3. Then we have in parentheses 2 times A, which is -2, times our B, which is -3 minus 1, close parenthesis, close absolute value. So we would go through, do our order of operations in there, and see what we end up getting. So inside these absolute values, there is another form of grouping. There actually are some parentheses here. So we're going to go ahead and work on that part next. So in these parentheses, we have some multiplication. So we rewrite everything else. So we got our negative sign, absolute value, 5 times the negative 2 plus 3. So then we solve this parenthesis. So we have 2 times the negative 2, which is negative 4, times the negative 3, which is going to be a positive 12. So now we have 12 minus 1. So over here, I'll continue solving it. So we have 5 times the negative 2 plus 3. If I take 12 minus 1, these parentheses now become an 11. So then we move on to our multiplication division in this, because there are no exponents. 5 times negative 2 is negative 10. 3 times 11 is 33. So we have this negative 10 here with a positive 33. That is going to get us a positive 23. So 23 is 23 units from 0. So the absolute value of 23 is 23. But there's a negative on the outside. Since the negative's on the outside, it would stay there, getting us a final answer of negative 23. So you got to pay attention to where that negative is placed so that you can accurately get your answer to this. So this next part is going to be where our absolute value acts as grouping, because we have operations on the outside of the absolute value. So it says evaluate, and then we have 23 minus, let me zoom out, with 23 minus, and then absolute value 3 plus 4x. It wants us to plug in 2 for x. So we'll have 23 minus absolute value 3 plus 4 times 2. So we have to do this absolute value first since it's grouping. So we keep 3. 4 times 2 is 8. If we go ahead and we add those, 3 plus 8 is going to get us 11. 11 is 11 units from 0, so the absolute value of 11 is 11. But there is a subtraction sign there, so this still stays subtraction because the subtraction sign is on the outside. So we have 23 minus 11. If I take 23 minus 11, that is going to get me an answer of 12. Now to justify, you would have wanted to say what your steps were. I didn't have enough room here, so I'll just kind of say what the steps were. So that first one, when I plugged in 2, my statement would have been replace x with 2. So that's by substitution. Then I took the 4 times 2. So my second step, where I have that 8, I would have wrote multiply 4 times 2 equals 8. For the next one, where I changed the 3 plus 8 to 11, I would have said for our 23 minus absolute value of 11, 3 plus 8 equals 11. When I took the absolute value of 11 and got 11, so where we have 23 minus 11, I would have said the absolute value of 11 equals 11. And then where we got 12, our reasoning would just be simplify. Okay? So now we have this final problem over here on the side. It's going to act the same as the one I just did because we have absolute values, which are going to act as grouping. So we go ahead and we write everything that would stay the same. So our 1.4 minus 2.5. We have an absolute value, 5y. So instead of y, we plug in negative 3. Then we have plus 0.6. So if we justified here, this would have been where we put replace y with negative 3. And that's because substitution allows us to do that. Then we actually have to go through and solve our grouping, which is our absolute value. So inside our absolute value, there's no more grouping. There are no exponents, so we move on to the multiplication. 5 times negative 3 is negative 15. So plus 0.6. So we would say multiply 5 times -3 equals -15. Then we got 1.4 minus 2.5. Now we actually finish solving what's inside this absolute value. So a -15 plus a 0.6 is -14.4. So our reasoning here could be -15 plus 0.6 equals -14.4. So we just replace it with what it's equal to. We would take the absolute value of -14.4. So we rewrite everything else. Oops, hit my pen. The absolute value, -14.4, is 14.4 units from 0. So it makes it positive. So absolute value of -14.4 equals 14.4 for our reasoning there. Now we would multiply those two numbers. So 2.5 times 14.4 is 36. So our reasoning would be -2.5 times 14.4 equals -36. That's why it's subtraction. Then we would go ahead and actually subtract there, which gets us a -34.6. So that would be our answer. And our final reason could be to simplify. Okay. So that is it for the 1.5 notes. The main thing you need to remember is the absolute value of any number is going to be the positive version of that number. So if it's 5, the absolute value is 5 is 5. If it was -5, the absolute value of -5 is +5.